So in this recording, we will see how we can use Milvius vector database to load. First, we'll create a collection in Milvius, then we'll load some embedding in Milvius, and then we'll see how we can use cosine similarity to retrieve relevant chunks based on a query, right? So what I did in the cosine similarity is I also gave a threshold based on which the chunks needs to be retrieved. This threshold addition was not adequately mentioned in another documentation, so it took me some time to understand how to use it. So that's what I will share today. So I have three pieces of code here. The first piece is the first one is the code that creates a collection in Milvius. Now, what I have done is I have created a free cluster, Milvius cluster on Zilli's cloud. This is for training purpose. Can use it. So I created, right now I don't have any collection. So the first program that I have creates a collection. I'll quickly go through it. So here I'm getting the OpenAI key, the cluster endpoint, and the token from the environment variable. Now, how you can get the token is if you go to API keys, then you can, this is your API key, right? So you can copy this and use it, right? So let me go back to my free cluster, right? So yeah, so this is a token. And for pip install, you need PyMilvius, OpenAI, because of the embedding model. I am using the embedding model from OpenAI. That's why this is required. LangChain community, because to show this experiment or to show this demonstration, I'm using recursive text splitter from LangChain. And tick token is required to calculate during recursive text splitter, right? I also gave how many tokens it should use, right? That's why the tick token is required. So going back to the code, I create an instance of Milvius client here with the cluster endpoint and the token. And then I use the create collection function, give a collection name. Since I will be using the OpenAI embedding model, the 1536 dimension one, which is actually this model here, text embedding 3 is the small, right? I'll be using that, which is 1536 dimension. And the metric type, I will use cosine distance. So while creating the collection, you need to mention whether you will use Euclidean distance or cosine distance or Manhattan distance, right? So I'll be using cosine distance. That's why I gave the metric type equal to cosine. So let me run this code. So after running this code, we'll go to my cluster and we'll see that the index is now created. So if I go back to the cluster, I should be able to see the collection. So the collection has been created. It will not have any data right now. It is empty. The next one will use to load some data. Now, what data will load? So what I did is from the internet, I took Obama's speech on stem cell research, right? This is the content of the speech. This is what will chunk and load to Milvius. And how I did it is, again, I have the Milvius client instantiated here. For embedding, I'm using text embedding 3 small. Dimension is 1536. Although here I don't need it, the dimension I need here. Here the dimension is not required. Then I create an OpenAI client. Then I'm reading or extracting the content from the speech text. And then I'm using the recursive character splitter from LangChain. Chunk size of 100 tokens, 0 overlap. So after I get then using text splitter, I split the text, and for each text in text, I convert it into the document schema of LangChain, where the page content contains the text and the metadata is the source, which is the Obama speech.text, right? I have a single source here. So after this, I will have my documents list populated with all the chunks. Now, for each of the chunks, now I am populating the docs list and the sources list. We have only one source for each doc, right? And then finally, the vectors. I'm creating the vector embedding here. So for vec in, so this is where I am calling the OpenAI embedding model. I'm inputting the list of docs, right? And the model name is the small model, text embedding 3 small, and dot data is giving me the embedding back as a list, right? So if I have 3 chunks, I'll have 3 embeddings. If I have 4 chunks, I'll have 4 embeddings. Then I'm creating the data to be loaded into Milvius. So where I have the attributes that I'm storing in Milvius is the ID, the actual vector, the text, the corresponding text of that embedding, then the source. The source is Obama speech.text, right? And then finally, I'm doing a client.insert, giving the Milvius embedding, like the collection name and the data, right? This is the data. So if I have 3 chunks, then there'll be 3. If I have 4 chunks, then 4 data, right? Let me run this, and then we'll go to Milvius and see how the data looks like. So so it is done. Now, if I go here, I should be able to do a data preview, right? So the data has been loaded, right? This is the vector embedding. This is the text. This is the source, right? So these are all the vector embeddings that I have. There are 24, total 24 chunks, right? Now that I have created the collection, loaded the embeddings, right? Let's do retrieval. Now retrieval again, I created instance of the client. We don't need this for retrieval right now. This is my query. How many Americans develop Alzheimer's in a year? So in Obama's pitch, there is actually a, let me actually show this. Oops. Each year, 100,000 Americans will develop Alzheimer's disease. That's what was there in the speech, right? So I asked a question, how many Americans develop Alzheimer's in a year? The query, so I'm converting this into embedding right now. So this is the query vector. And then the parameters that I'm giving, the metric type is cosine. The params, this is important. This is what I actually had to do a lot of reading of Milvius to find out how do I put a threshold for the cosine similarity score. So radius and range filter, these are the 2 parameters. So when I say radius 0.5 and range filter 1.0, that means I want to filter. So when I match the query vector with the embedding vectors in Milvius, I want all those vectors for which the similarity score is between 0.5 and 1, right? So that is what radius and range filter gives me. It's not that intuitive. It was like radius I would have it would be intuitive like for Euclidean distance, right? For cosine distance, I really did not understand why the name is radius, but to make it work, like and this is how it works in Milvius. If you put the radius and the range filter for cosine distance. That means that you are looking for vectors for which the score is between 0.5 and 1, right? This is your um, minimum score. This is the maximum score, right? So then I'm doing the search collection name. This is the collection name, query vector. This is the query vector that we have created here, right? And then I am saying, give me the top 3 matches with the embedding vectors. And the output fields, I want the text and the source. So if you remember, we added text and source as metadata along with the vector, right? We are saying that we need the text and the source, and the search parameters is parameter, right? This is metric type is cosine, and we want to filter the vectors which are between 0.5 and 1, right? And once I get the response now so I have only one query, right? One query, right? So for Q in queries, I'm printing the query, and for a result in the result, right? I am printing the result, right? That's what I'm doing here, right? So this will give me for this particular query, what is the result that I got, right? So let me run this. So if you see it brought this chunks back, this has a 0.5 score. So this each year, right? This was what I was looking for, right? It pulled this along with the text and the source, right? Ohms speech.text. So this is the only vector that matched the like between 0.5 and 1. I got this, right? So this is how we put the threshold, right? This is how we put the threshold in while we are doing a cosine similarity, right? That's what I wanted to show. Thank you. And talk to you later. Bye-bye.